Hello, good afternoon. Myself Revansiddappa from Civil Engineering Department, Marri Laxman Reddy Education Society. So today's our topic is Theodolite Surveying. Introduction about Theodolite Surveying. So first of all, we will go through the syllabus. The syllabus contains Theodolite Surveying, types of Theodolite. There may be three types of Theodolite: vernier and non-vernier, transit and non-transit Theodolite. After that, the fundamental lines between axis and axes. Then temporary adjustment of the theodolite. Next topic is the horizontal angle measurement by the repetition method and reiteration method. So after that, so in this theodolite surveying, it is the measurement of vertical angle. So after that, in this syllabus, the main topic is next one, trigonometrical leveling. So by the trigonometric concepts, by trigonometric formulas, we are calculating the horizontal distances and vertical angles and vertical distances. So after that, by using a theodolite with some alteration, that we call it as an tachometric surveying. In this surveying, we are measuring the horizontal distance and vertical angle, vertical height between the multiple points by using an tachometric constants. So this is about the syllabus of the theodolite surveying. So next one is the learning outcomes. After studying this topic, theodolite surveying, the students are able to apply the knowledge to calculate angles, distance and levels between multiple points. The second outcome is the understand working principle of survey instruments and apply the knowledge of trigonometric leveling. Next outcome is understand and apply the corrective measures on measurement of errors. So let's start the topic, theodolite surveying. So here you are, it is a visible of the theodolite. This is the instrument commonly used for the precise surveying. So coming to the definition, the theodolite is a precision instrument for measuring angles in the horizontal and vertical planes, and the system of surveying which includes or which we use a theodolite instrument for the surveying, that surveying we call it as an theodolite surveying. The next one is the uses of theodolite. By using a theodolite, we can measure the horizontal angle between number of points, for example between the two poles from the stationary point. And next one is the measurement of vertical angle. Measurement of vertical angle between line of sight and the top of the building. We can measure it. Measurement of deflection angle. If suppose we need to measure the deflection angle with the previous survey line, then we can use the theodolite instrument. Next, measuring the magnetic bearing with respect to the magnetic north or north pole, we can measure the magnetic bearing of the survey line. Next one use is the measuring the horizontal distance between 2 points. By the trigonometrical formula, we can take the angle and distance between the points from a stationary point. After that, we can calculate the horizontal distance between two inaccessible points. For that also we are using a theodolite instrument. Next one is the for finding out the vertical height of an object. So by the trigonometrical formula and by measuring the vertical angle and the distance between the station and the object, we can calculate the height of the object by using theodolite instrument. Next, finding difference of elevation between various points. By fixing the telescope of the theodolite to a 0 degree, 0 minute and 0 seconds, we can use it as a leveling instrument, as a dumpy level. So by that also we can calculate the elevation of different points. After that, we can use by the theodolite telescope for the ranging a line, for the extension of the line, for determining the intermediate between the points we can use the theodolite. So here about the uses. Next, coming to the topic, that is the types of theodolite. So normally we are classifying into two types, transit theodolite and non-transit theodolite, depending upon the movement of the telescope. If suppose the theodolite telescope, we can revolve it up to 360 degree or up to 180 degree. That possibility of revolving the process, we call it as an transiting, right? If the theodolite telescope we can transit, then that type of instrument we call it as an transit theodolite. If the telescope we can't rotate up to 180 degree or 360 degree, that theodolite we call it as an non-transit theodolite. So depending upon the measurement arrangement, depending upon the taking the reading arrangement, we can classify into vernier theodolite and non-vernier theodolite. So in vernier theodolite, while taking the measurement, we can measure the angle with an accuracy of 20 seconds. So that is possible with the help of arrangement or fitting, call it as a vernier scale. So if the theodolite is having that arrangement, that type of theodolite, we call it as a vernier theodolite, right? So transit theodolite, non-transit theodolite and vernier theodolite. So here is the diagram of or picture of the theodolite. So here you can see the telescope. This is the left side photo and this is the right side of the instrument photo. So here it is a telescope, eyepiece, object glass, and this telescope is supported on the A-frame support. So here for measuring the horizontal angle, we are having a theodolite with horizontal circle. For measuring a vertical angle, we have a vertical circle at the side of the telescope. So here, up to this arrangement, in the left side, you can see here to here, we call it as an tri-branch. It includes leveling head and trivate. So for the details, you can see here the transit theodolite, the parts of the transit theodolite. First of all, you can see here, this is the cross section of the theodolite, cross section diagram of the theodolite. So first one, the central line, this is the vertical axis, and here this is the horizontal axis or Trunnian axis on which the telescope will revolve in a vertical plane, horizontal axis. In vertical axis, the whole instrument will rotate in a horizontal plane about its central axis. That axis we call it as a vertical axis. In the left side, the instrument is having a vertical plate, clamp screw, right? Then here, for measuring a horizontal angle, we are adjusting the plates, horizontal plates, upper plate and lower plate. So normally this upper plate and lower plate will support it at this spindle. With respect to the lower plate, the upper plate will rotate. After that, we can get the reading at the verniers, vernier A and vernier B. So after that, this is the tri-batch and this is the trivate, and this one is the leveling screw. So including these three, from tri-batch to trivate, we call it as an leveling head. So the whole instrument is supported on the tripod head and tripod leg. So most clearly, The transit vernier theodolite, which consists or which is will have leveling head, lower circular plate, upper plate, telescope, vernier scale, T frame, or sometimes we call it as an A frame. Next, plumb bob and tripod stand. So here is the spindle arrangement, upper plate and lower plate. So while rotating the instrument in the vertical axis on a horizontal plane, the lower plate that one is clamped with the lower clamp. That will be clamped with the lower clamp. So after that, rotating the instrument, the upper plate will rotate with respect to the lower plate's position. After the clamping the upper plate, the both leveling head spindle will attach each other. After that, we can get the reading at the vernier. Some common terms which we are using in the theodolite surveying. First one is centering the instrument. Centering the instrument means we are placing the instrument over the station by spreading the legs of the tripod and bringing the instrument to the correct position by the help of plumb bob. Next one is transiting. Transiting means rotating the telescope in a vertical plane about its horizontal axis of about 180 degree. That one we call it as an transiting. Face left observation. While taking the reading, if the vertical circle is left side of the telescope or observer, that face we call it as an face left reading. If the vertical circle is right side of the observer while taking the reading, that one reading we call it as an face right observation. So here I can see that this is the face left observation. In both the picture, it is a face left observation because while taking the reading from the eyepiece, the circle is left of the observer in this case also. Next, changing the face. The operation of transiting from face left to face right, that process we call it as changing the face. Next, swinging the telescope. If the telescope is rotating in a horizontal plane along its vertical axis in a clockwise direction or anti-clockwise direction, that horizontal rotation we call it as swinging the telescope. Next one is line of collimation. If the imaginary line from the center of the eyepiece to center of the object glass and its continuation up to the object, we call it as a line of collimation. Next one, axis of telescope. It is similar to a line of collimation, but the difference is it is an imaginary line which is joining from the center of the eyepiece to center of the objective. This is the axis of telescope. Next, axis of bubble tube. So here is the bubble tube for leveling purpose. So normally the bubble tube is having a curve with the 1 second difference. If we draw the tangent line on this curved level tube, that tangential line we call it as an axis of telescope. Next term is vertical axis. It is the axis of rotation of the telescope in horizontal plane. Next, horizontal axis, it is the axis of rotation of the telescope in a vertical plane. temporary adjustments at every setup of the instrument. After every setup of the instrument, if we are making some adjustment, that adjustment we call it as a temporary adjustment. And the permanent adjustment, that will be disturbing a relationship between fundamental lines. Next, coming to the fundamental axes of theodolite and its relationships. Normally we know the vertical axis is a fundamental line which is drawn in a vertical direction, vertical axis, and horizontal axis normally it must be with the angle of 90 degree. That means the horizontal axis makes 90 degree with the vertical axis. And next one is line of collimation or line of sight. The line of collimation or line of sight which must be perpendicular to horizontal axis as well as perpendicular to vertical axis. These three are the main fundamental lines: vertical axis, horizontal axis, and line of sight. Well, coming to the horizontal plate, that means we are considering a horizontal plane which is perpendicular to vertical axis, and the horizontal angle will measure on this plane, horizontal circular plate plane. Like that, for measuring a vertical angle, we are having a vertical circle. So, by considering that vertical plane on which we are measuring the vertical angle, that must be perpendicular to horizontal axis. Horizontal circle, vertical axis, vertical circle, horizontal axis. Next, coming to the eyepiece, that means the stadia hairs will be fixing on the eyepiece at the eyepiece or diaphragm. If we consider that plane, that one is the eyepiece plane, and similarly the objective plane. So these are the fundamental lines or fundamental conditions which must be considered while surveying. Next one is temporary adjustments. As we know, at every setup of the instrument, we need to do some adjustments. That one we call it as an temporary adjustments. The first one is setting up the instrument and centering over the station. First, we need to spread the legs of the tripod and place the instrument above the station with the help of plumb bob. That one we call it as an setting up the instrument and centering of the instrument. Next one is leveling by making the telescope and vertical angle, that is a 0 degree. After that, elimination of parallax. We need to set the eyepiece and focusing screw until we get the clear image of object and as well as crosshairs. Next, coming to the methods of horizontal measuring. By the two methods, we can measure the horizontal angle by repetition method and reiteration method. For this purpose, in repetition method, we need to place the instrument over O station. We need to set the horizontal angle 0 degree and we need to bisect at A. After that, we need to tighten the lower clamp and loose upper clamp. We need to bisect B. Then, by taking the reading from vernier A and vernier B, we can get the average reading of horizontal angle theta. So this is one repetition. Again, if suppose theta is the 30 degree angle here in this case, then for the second repetition we need to start 30 degree from A and we need to measure up to bisecting B. This must be theta 1. Theta 1 must be 60 degree. Third repetition, theta 2. Theta 2, it may be 90 degree, 30 minutes. By the average of these three, we can get the angle between AOB. Next, reiteration method. So here we are starting the taking angle from A, and similarly we can measure the angle B. After that, B to C, C to D, and D to E. The angle alpha, lambda, beta, gamma, and theta is the angle between the points. Oh.